Hello everyone and welcome. So far we have learned about new language, and in this part we are going to learn about how to write a smart contract for Aptos. First of all, as you can see, I have created a project here, created the basic structure, but we are going to fill up this contract together. First of all, this contract is called the vault or vault, and the ideology is that the admin can give allocations, and the addresses that have the allocation can actually claim their tokens. And also from this vault, admin will be able to withdraw tokens, but not the ones that has been given as allocation. So if I have 100 tokens and I gave 20 allocations to different addresses, the maximum amount that I can withdraw as an admin is 80 tokens. And addresses claim their tokens based on how much allocation they have. Here we are going to use signer and coin, and specific the Aptos coin. After that, we are going to have event handles. So we are going to create events. With these events, we are going to let frontend know what's happening in the contract. So when we created the event, as we talked previously, the frontend will be able to know what we are doing here. Also, we are going to use this account. We are going to get to this later, but just a brief explanation. We are going to create a specific account for the vault. So the vault object will have its own account. And finally, we are going to use tables. So tables are like vectors, but we also have keys. So instead of just putting everything in a vector, we are going to have key value pairs. Also, we have some error codes. The first one is if the transaction sender is not the admin, we are going to return this. The second one is insufficient balance, and the third one is no allocation. In Aptos, we are actually returning numbers, but to understand it better when we read the contract and also to change it from one place, we are going to use this error codes, because if I just put one everywhere, and if I want to change one error code, then I need to change it everywhere. But with this methodology, instead of changing the number in every occurrence, we can just change the constant and the error will be changed in the whole contract. We also have 4 different events. The first one is for the allocation made event. We are going to fire this up when there is an allocation. And we also have one for claimed. So if a user claims their token, then we are going to return this event. We have token deposit event for the deposition of the token to the contract, and finally for the withdraw. As you can see, we have our vault struct here. It has a key, so we are going to use this as the object, the main object. It's going to have the admin, and it's also going to have the vault address. We are also going to provide the allocations as a table, as we said that we are going to have a key and value pair. Here, the key will be the address and the value will be the U64. So this address will have this much of an allocation that the user can actually claim. We are going to hold the total allocated amount in the contract, the total balance of the contract, and we are going to also store the events. And the reason for that is with only one struct, we are going to have all the information that we need in this contract. So this is going to be the base of our contract. And in the next video, we are going to start implementing this contract starting from the init function. Thank you very much for listening to me on this video, and I will see you on the next one.